Hi, everybody. We're continuing our review with uh, 1.3 linear functions. So the standard form of a linear equation is ax plus by plus c. The a, b, c are constants. The x and y are the variables. And this would look like 3x minus 2y equals -7, or -5x plus y over I equals 14, or so on and so forth. So this is called the standard form of a linear equation. And the next very famous form is what we call the slope-intercept form. And this is surely something you've seen before. And the slope-intercept form is the famous y equals mx plus b. M is the slope, and b equals the y-intercept. I'm going to show you in a second what that means. This would look like y equals 2x plus 5, y equals -5 sevenths x plus 4, or so forth. And I want to switch over to Desmos now to give you some examples of, show you a little bit of how this works. Let me share my screen. Well, I'm going to switch cameras. Oops, I didn't want that. I have to switch cameras. True. There you go. And I'm gonna share the screen. And we're gonna go to Desmos. Okay. So y equals mx plus b. That's my equation up here. So let's let b equal. I'm gonna make let b equals 0 for now. So if you notice, now let's just let m equal 1. Okay. So if b equals 0, it's a line through the origin. If I let b equal 1, then it's going to be a line through the point 1. If I let b equal 4.3, the line is going to hit the y-axis at 4.3. So the line is always going to hit the y-axis at the b point. And of course, if b is a negative number, then so if b is -1.9, it's going to hit the y-axis at -1.9. So that's always the way this works. It's pretty awesome. It's cool. It's tremendous. It's fantastic. So I should have the right camera. Yes, okay. And if let's let b back to 0 here. Now let's look at m. M, as you notice, is increasing. Increasing means that as the x goes towards the positive direction, the y is going up higher. That means it's an increasing function. Y increases as x increases. Now, if the slope becomes bigger, so right now the slope is 1. If I make the slope bigger, if you notice when the slope becomes bigger, the line gets like steeper. It's increasing, but it's increasing more steeply. If the m gets smaller, so here's 1 again. Now, as it gets smaller, 0.8, 0.6, 0.4, 0.3, you see what I'm saying? As the slope gets smaller, the line gets more shallow. The hill is more, it's a more shallow hill. And that's important to know. If m equals 0, then it's going to be, the line is going to be completely horizontal. And if m becomes negative, now it's going to have a negative slope. It's going to be a downward slope, meaning as x goes in the positive direction, y decreases. Y gets to be lower number. And if m is a bigger negative number, then it decreases more sharply. So that's what my m does. My m it goes from a very sharp increase to a very sharp decrease. It crosses a flat line in the middle and everything in between. And that is the story. That is what m does, and that is what b does. Let me stop that because it's giving me a headache. Now let's go back. And you're probably all saying here, like, wow, this M thing is like really important. I wonder how we figure it out. Well, I will tell you that shortly. First, I want to give you the third form that linear equations are written in, and that is called the point slope form. Point slope. And that is y minus y1 equals m times x minus x1. So there's my m again. And that is the point slope form. So we just put it in this little box here. And this is the m equals the slope again. M represents the slope. And the line goes through, this is a line that goes through the point x1 comma y1. So if I would have, and if I have if I have if I have an equation, y minus 7 equals 4 times x plus 2, that means that the slope of this line is equal to 4. I get it from that number right there. And it goes to the point -2 comma 7. Why -2? Because x plus 2 is the same as x minus -2. So it has to be what x is subtracting. So it's x minus -2, that's -2, and that's y minus +7 is my +7. And that is that form. So now I could take this equation here and I can solve for y, so to speak, and essentially put it into the slope-intercept form. So here's what I'm going to do. I'm going to add 7 to each side. I get y equals 7 plus 4 times x plus 2. I just added 7 to each side. Y is equal to 7 plus 4x plus 8, because 4 times 2 is 8. And finally, y equals 4x plus 15. So now I know, well, again, the slope is still 4, that hasn't changed, but I have this 15 here, which tells me that that is the y-intercept. 15 is the y-intercept. And let's graph this. I'm going to graph this actually both ways. So let's go to Desmos. So I have to go switch my cameras again. There we go. And I'm going to share my screen. And here's Desmos. Okay. So y equals, so let's just come here. So now we have the equation. The original equation was y minus 7 equals 4 times x plus 2. X plus 2. And gee, I wonder where this is going to hit the y-axis. Well, let's find out. Let's take a look. I have to shrink this a little bit. Look at that. It hits the y-axis right at 15. 0, 15. So indeed, the just as I saw from the equation. Now I'm gonna retype this equation. I'm also going to put this in mx plus b form. I'm going to let b equal 15. B is going to, oh, b can't equal 15. No, I have to change this. B is going to go up to 15. 16. So I'm just going to let b equal 15. So here we go. So b is going to equal 15. Look at that, it hits it right there. But I still got to fix the slope because this is negative. I could set the slope equal to 4. 4. And it is 4 right now. So notice that now my y, this top is y equals mx plus b, y equals 4x plus 15, because m is 4, b is 15. This guy here is y equals y minus 7 equals 4. And notice it's the same line. It winds up being the exact same line. And that is terrific. That is terrific. Now, we could do another kind of problem. Um, once we have this, there's a lot of stuff we can figure out. But the first thing I really want to figure out, which is what I had said earlier, is how are we gonna get this mysterious M? Like I just told you M, but like, I want to know more about this M, this mysterious M. M does not stand for mysterious, by the way. It stands for mountain. Actually, historically, the M stands for the French word for mountain, which is I don't know what it is, but the French word for slope starts with an M. That's why we use y equals mx plus b. I'm not going to claim I always do that. I just learned this recently somewhere on. Oh, I forgot what it's called. Something like there used to be something called cha-cha. I don't know if it exists anymore, but anyway, that's the M. Let me switch to my newspaper. Okay, so this wonderful, beautiful, mysterious M. So if you have an equation, if I'm given 2 points, and they are x1 comma y1, that's my first point, and x2 comma y2, that's my second point, the slope of the line connecting these points is going to be y2 minus y1 over x2 minus x1. So let's say I have 2 points. Let's say I have 2 points. Let's do an example now. So I have 2 points. My 2 points are going to be, I don't know, 2 comma 7 and 6 comma 9. So what is the slope? Well, the slope, M, the slope is going to be, M is going to equal 9 minus 7, that's y2 minus y1, over 6 minus 2, which equals 2 over 4, which reduces to 1/2. And suppose I would ask for the equation of the line that connects these 2 points. Well, what I do is I pick either point, it doesn't matter which one, pick either point, and let's just do the 2, 7. 7's a nice lucky number. And I'm going to write the equation as y minus 7 equals 1/2 x minus 2. So I chose my first point, 2 comma 7. The 7 went here and the 2 went there. Y minus 7. Now I could have chosen the 6 and the 9 instead. I could have chosen the 6 and the 9 instead. Before I do that, I want to take this and put it into mx plus b form. So I'm going to add 7 to each side. And I'm going to distribute. So I get y equals 1/2 x minus 1 plus 7, or y equals 1/2 x plus 6. Now, I want to say, well, I chose that first point, the 2 and 10. What if I chose the other point? Would I get a whole different answer? What's going to happen? Let's see. So if I choose the second point, I have y minus 9 equals 1/2, because the 1/2 doesn't change, times x minus 6. So this looks totally different from that. Here it's y minus 7 equals 1/2 x minus 2, and this is y minus 9 equals 1/2 x. It looks like I got two totally different lines. So what's up with that? I'm gonna add 9 to each side. So I have y equal, and I'm going to distribute 1/2 x plus plus minus 3 plus 9, or y equals 1/2 x plus 6. Look at that. In the end, I got the exact same line. In the end, I got the exact same line. I want to look at something which I kind of glossed over. Y2, so x1, y1 is the first point, x2, y2 is the second point. But I didn't say, well, I just said 2, 7, and 6, 9. I didn't say what was what. Like, I just decided that this should be my x1, y1. That should be my x2, y2. Maybe this is my first point, and that's my second point. I didn't really write any order. I happen to write one on the right, one on the left. That doesn't, what does that mean? Well, the answer is you could do it either way, and it won't matter. Because if I do it the other way, meaning I consider the 6, 9 to be my first point, so I would get m equals 7 minus 9 over 2 minus 6, which equals negative 2 over negative 4, which cancels out, and I get 1 over 2, 1/2. So I get the same answer. So it doesn't really matter which, so students a lot of times stress out, how do I know which is x1 and y1, which is x2, it doesn't matter. As long as you're consistent, meaning that if I make this my first point, I can't, for the y, I can't, here's what I mean. This is no good. This is bad. If I would do 9 minus 7 on top and 2 minus 6 on, like on top, I make that the first point, and on bottom I make the other one the first point. That's going to give me the wrong answer. That's actually going to give me negative 1/2. It's going to give me the exact opposite. So this is bad. Bad. So don't mix and match. You could do either one. I could make this one and that. I can make this point 1, that point 2, or I can make that point 1 and that point 2. That's fine, but I can't at the top of the fraction mean different than the bottom of the fraction. I have to be consistent. That's all I'm saying. Okay. So what I want to do now is let's look at this on Desmos. That should be fun and interesting and exciting. So let's I'm gonna switch cameras. Okay, switch cameras. Now I'm gonna share my screen. And we're in Desmos now. So I'm gonna take here's what I'm gonna do. I'm gonna look at y equals mx plus b. I'm gonna let x equal 1/2. I'm sorry, let b equal 6. Let b equal 6. I'm gonna let m equal 1/2, which is 0.5. And now I'm going to fix this up with the equation I got before. Y minus 7 equals 0.5 times x minus 2. And notice when I do that, this line is exactly on the y equals mx plus b line. I'm also going to type in the second equation I got, y minus 9. This is when I chose the other point. y minus 9 equals 0.5 times x minus 6. And look at that. Again, it's all good. And I want to take this started with 2 points. I want to make sure that the 2 points I started with are on that line. So we started with the point 2 comma 7, 2 comma 7. Okay, 2 comma 7. And the other point that we used, originally I said connected 2 dots. The other point was 6 comma 9. And not the 0, it's really 9. And if you notice, both points are on the line. There you go. So 2, 7 and 6, 9 both are right on that line. So everything works out. All 3 equations wound up forming the same line, plus my 2 points. Because don't forget, this problem started. I said, hey, we got 2 points. Let's put them into one. Let's put them into one. Let's get the equation of the line. So you see we got 3 different possible versions of the equation. They all wind up being the same line, and all 3 of them, not only they're the same, they all go through the original 2 points that I started with. Originally I was given 2 points. I was given 2 comma 7 and 6 comma 9, and we have the equation. That is a win-win-win. That is beautiful. Okay, everybody, let's now sometimes we might ask you to find the X intercept. So if you have an equation y equals 3x minus 7, the way to find the X, see the y-intercept is very easy when you write it like this. You just take that last number, -7. That's the y-intercept. But the x-intercept, there's one and only one way to find the x-intercept. Well, I shouldn't say one and only one way, but a very reliable way, always reliable way, is to set y equal to 0. Because on the x-axis, all the y values on the x-axis are equal to 0. So I want to find the point on this line where y equals 0. So I just set y equal to 0. And then solve for x. So the x-intercept is going to be 7/3. The y-intercept is -7, and the x-intercept is 7/3. And that's really that's how you find the x-intercept for any line, any line, any equation. Sometimes you'll have 2 lines. You want to know where 2 lines. Sometimes, boy, I can't talk anymore. Sometimes you want to know where 2 lines intersect. Sometimes you want to know where 2 lines intercept, or is intersect. You want to know where 2 lines intersect. I feel like I'm spelling that wrong. Maybe that should be S. Okay, that looks better. Intersecting lines. So, for example, if I have a line y equals 2x plus 5, and I have another line y equals 7x minus 15, well, since that's y and that's y, so 2x plus 15 is equal to y, and 7x minus 15 is equal to y. All I got to do is take 2x plus 5 and set that equal to 7x minus 15 because they're both equal to y, then they have to equal each other and just solve for the value of x that makes that happen. That's a simple way to find the point where 2 lines intersect. By the way, if 2 lines intersect, that means I want a point which is on both lines. It satisfies each line. Anyway, I'm going to set them equal to each other. 2x plus 5. I'm going to set that equal to 7x minus 15. I'm going to subtract 2x. I'm going to add 15. I get 20 equals 5x, and therefore x equals 4. Now, I want a point of intersection. That's just an x value. And this is not on. So I have to take x equals 4 and plug it into either equation and solve for y. Now I'm going to plug it into both equations because that's a way of checking your answer. So y equals 2 times 4 plus 5, which is 13. If I do it this way, I get y equals 7 times 4 minus 15, 28 minus 15, which is also 13. So my point of intersection is going to be 4, comma, 13. That's my dazzling answer. Oops. So these intersecting lines intersect at the point 4, comma 13. Okay, everybody, it's been loads of fun and inspiration recording this video, and we'll see you guys of this review of linear functions, and we'll see you all next time. Bye.